Hello, this is Mr. Stansbury. I'm going to take you through the notes on dependent events. At the end of this, you should be able to say I can find the probability of dependent events with and without replacement. All right, so first thing, two or more events are dependent if the occurrence of one of the events has an effect on the occurrence of the other event. So, like for example, if you're pulling marbles out of a bag, like actually I'll show you an example on this in a little bit, but if you're pulling marbles out of a bag and then you pull a marble out and then you keep that marble out of the bag and then you reach in for a different marble, what happens on that first pull of the marble will change the probability of pulling whatever kind of marble you're looking for on the second pull. I'll show you an example here in a second. But first off, if A and B are dependent events, then if you're looking for the intersection of A and B happening, what you do is you multiply the probability of A happening times the probability of B happening, given that A has already happened. I know that sounds kind of weird. It looks like this: probability of A intersect B equals the probability of A times the probability of B, given that A has happened. And I'll show you what that means here. So here's an example. Let's say we've got 14 total things in A, and we've got 11 total things in B. If I want to figure out the probability of this thing happening here in the middle, the probability of A and B, which is 4 out of the 21. Another way you can find that is finding the probability of A, which is 14 out of the total 21. And then you multiply that by the probability of B happening, which is just as 4, given that A has already happened. So A is going to be the only group that we're choosing from, so that's the 14. So of these 14, which are also in B, 4. So that's the 4 out of 14. And if you go through and you cross off, let's try it this way. Cross off those, you end up with 4 out of 21, which is the same thing. Okay? Okay, when an experiment involves sampling, without replacement would be dependent events. So if you pull something out of a bag and then you don't put it back in, that's not replacing it. That would be dependent events. If you have an experiment which involves sampling and you do replace it, so you put the marble back in, those would be independent events because it won't matter because you're putting the marbles back in. It's always going to be the same amount and same type of marbles that you're pulling out. Okay, so for example, here's the marble example I was telling you about. So find the probability of drawing 2 red marbles from the bag with replacement and without replacement. So probability of drawing the first red marble from the bag, there are 3 red marbles out of 7 total, right? Now it says with replacement. So if you pull that marble out, that marble's gone now, but then you put the marble back in and then you draw again. That's what this is talking about with replacement. So it's a 3 out of 7 chance that I'll pull that red marble out. I put that marble back in and then I try to pull another red marble out. That's still going to be a 3 out of 7 chance, right? So that's going to end up being 9 out of 49. 9 out of 49 probability that you will be able to draw 2 red marbles in a row from the bag. Okay, now without replacement, again, we're starting like this, but now we are figuring out the probability of pulling a red marble out first, so that's still 3 out of 7. Okay, but now we take one of those. Let's see, why can't I get that to work? Okay, there we go. We pull a red marble out because that was our 3 out of 7. So now the second time that we reach into the bag, that one of those red marbles is missing. So now there's only 2 possible red marbles that we're trying to grab, and there's only 6 total marbles to grab from. So now that turns into 6 out of 42. Okay, so just so we kind of get a better idea of what the change is, so we go to 9 divided by 49. This is going to give us 18.4%. Right, but now with the second one, we're not replacing it, so that's 6 divided by 42, which is 14.3%. Okay, so it changed by about 4%. Not huge difference, but it is still a difference. Okay? All right, let's take a look at another example. All right, first let's take a little comedy break.
That's the best one I've ever seen.
Okay. All right, let's take a look at another example here. Example 17. A bag contains 7 tickets to see the Gert Johnnies and 5 tickets to see the Faith Tones. 2 tickets are randomly selected from the bag. Find the probability that both are for the Faith Tones if tickets are replaced. So, probability, let's see, we got 5 tickets to see the Faith Tones, 7 to the Gert Johnnies and 5 to the Faith Tones. So we've got, so that means that there are 12 total that we're picking from. Okay, and then, so there's 7, let's do this, 7 for the Gert Johnnies and 5 for the Faith Tones, right? So both are for the Faith Tones if the tickets are replaced, so let's just do one at a time. So 5 out of 12 for the first one, and then the ticket is placed back in there, so then it's going to be another 5 out of 12. Okay, so that's going to be 25 out of 144. Okay. Both are for the Faith Tones if tickets are not replaced. So again, first one's still going to be 5 out of 12, but now you have one of those tickets out. So now there's only 4 left for the Faith Tones, and there's only 11 total tickets. It gives us 20 out of 12 times 11 is 132. Oops. Equals. So we do 20 divided by 132. And we get 0.151515. So that is 15.15 or 15.2%. Okay? And then for C, the first is for the Faith Tones and the second is for the Gert Johnnies. So let's see, the Faith Tones, we've got 5 to see the Faith Tones, so that's going to be 5 out of 12. We now have 1 less ticket in there, so it's out of 11, but how many? The second one is for the Gert Johnnies, and that's 7, right? 7 tickets. So that's going to give us 35 out of 132. And we calculate that. 35 divided by 132 gives us 0.265. So a 26.5% chance for that one, right? Yep. Okay, that's all we have for the first half of the notes here. If you have any further questions, make sure you ask in class. Thanks.